Hi everyone and welcome back to the channel. Ever wondered why your smartphone can recognize your face in milliseconds or how your voice assistant understands your commands so effortlessly? The secret lies in the dynamic duo of CPUs and NPUs. There are two types of processor that are revolutionizing the way we interact with technology. But what exactly do they do and how do they compare? So buckle up because today we are diving deep into the world of CPUs, NPUs and the matrix that defines their performance. By the end of this video, you will not only understand the difference between gigahertz and TOPS but also know why these chips are the unsung heroes of modern technology. So let's start with the basics. CPU, that we call it as central processing unit. Think of the CPU as the jack of all trades. It's the brain of your computer, handling everything from running your operating system to executing complex software applications. Whether you are gaming, browsing or multitasking, the CPU is the workhorse that keeps everything running smoothly. Neural processing unit, called it as NPU. Now meet the specialist. The NPU is designed specifically for the AI and machine learning tasks. It's the reason your phone can recognize your face, your smart speaker can understand your voice, and your camera can apply those fancy filters in real time. NPUs are built to handle massive amount of data simultaneously, making them perfect for tasks that require parallel processing. So here is a key takeaway. While the CPU is the versatile multitasker, the NPU is the precision expert excelling in AI-driven tasks. So here is a question that often comes up. Can a CPU do what an NPU does and vice versa? The short answer is yes, but not efficiently. A CPU can handle AI tasks, but it's like using a Swiss army knife to cut down a tree. It's all about getting the job done, but it's slow and inefficient. AI tasks require massive parallel processing, which CPUs are not optimized for. On the flip side, an NPU can perform general computing tasks, but it's like using a chainsaw to slice bread. Overkill and not practical. NPUs lack the versatility and system management capabilities of CPU. So the bottom line is CPUs and NPUs are designed to complement each other and not replace each other. Now let's talk about how we measure their performances. So gigahertz. This is the metric we use for CPU. It tells us how many cycles the CPU can complete in 1 second. For example, a 3.5 gigahertz CPU can perform 3.5 billion cycles per second. The higher the gigahertz, the faster the CPU can execute tasks like gaming, browsing, and multitasking. TOPS, tera operations per second. This is the metric for NPUs. It measures how many trillions of operations the NPU can perform in 1 second. For instance, an NPU rated at 10 TOPS can handle 10 trillion operations per second, making it ideal for AI tasks like image recognition and speech processing. Analogy of time: think of gigahertz as the speedometer in your car. It shows how fast you are going. TOPS, on the other hand, is like the cargo capacity of a truck. It shows how much work can be done at once. Both are important, but they serve different purposes. But wait, there is more. To get a complete picture, we need to look a few more metrics. Like number one, power efficiencies. NPUs are designed to be power efficient, which is crucial for battery powered devices like smartphone, laptops, and other IoT gadgets. CPUs, while versatile, can be power hungry when handling AI tasks. Number two, parallelism. NPUs excel at parallel processing, handling thousands of operations simultaneously. CPUs, while powerful, are better suited for sequential tasks. Number three, latency. CPUs have lower latency, making them ideal for real-time applications like gaming or system management. NPUs, while fast, may introduce slight delays in non-AI tasks. Number four, scalability. NPUs scale better for AI tasks. If you are working with larger neural networks, an NPU can handle the increased workload with ease. CPUs, on the other hand, struggle with scalability in AI applications. Number five, cost. NPU can add to the overall cost of a device, making them less common in budget-friendly options. CPUs, being more versatile, offer better value for general-purpose devices. So here is a pro tip. When choosing a device, consider what you will be using it for. If you are using into gaming or general computing, prioritize a powerful CPU. If you are into AI-driven tasks like photo editing or voice recognition, look for a device with a robust NPU. So why should you care about all this? Because understanding the difference between the CPUs and NPUs can help you make smarter buying decisions. Smartphones. Modern smartphones uses NPUs for tasks like facial recognition, augmented reality, and real-time language translation. The CPU handles everything else from running apps to managing the operating system. Laptops and desktops. If you are a gamer or a content creator, you will want a powerful CPU, but if you are into AI development or machine learning, an NPU or even a GPU will be your best friend. IoT devices. Some smart home devices like security cameras and voice assistants rely heavily on NPUs for real-time data processing. The CPU ensures the device runs smoothly overall. Here is a real-world example. Imagine you are using a photo editing app. The CPU handles the general interface and multitasking, while the NPU accelerates tasks like object recognition and background blurring. Together, they deliver a seamless experience. Now let's talk about some real-world examples of processor that includes NPUs. Number one, Apple A series and M series chips. Apple's A14, A15, and M1, M2 chips come with a dedicated neural engine and Apple terms for NPU. These are found in iPhones, iPads, and Macs. offering incredible AI performance for tasks like photo processing and Siri. Number 2, Qualcomm Snapdragon. The Snapdragon 8 Gen 2 and Gen 3 feature hexagon DSPs with integrated NPUs, powering flagship Android smartphones like the Samsung Galaxy S23 and OnePlus 11. Intel's Core Ultra processor. Intel's latest Core Ultra chips material like include an NPU for AI acceleration targeting laptops and desktop for tasks like video editing and AI-based application. AMD Ryzen with XDNA chip has an NPU-based Reliance AI engine designed for laptops and desktop to handle AI workload efficiency. Google Tensor. So found in Pixel phones, Google Tensor chips includes a custom NPU for AI tasks like real-time translation and computational photograph. So let's talk about the price difference. Devices with NPUs tend to be more expensive due to the added AI capabilities. For example, an iPhone with an A16 or M1 chip will cost more than a budget phone with a standard CPU. Similarly, laptops with Intel Core Ultra or AMD Ryzen processors are priced higher than those with traditional CPUs. So NPUs are designed for specific use and cases and users. So number one, AI developers and researchers. If you are working on machine learning models, neural networks, or AI research, an NPU is a must-have. It accelerates training and inference tasks, saving your time and computational resources. Number two, content creators. For video editors, graphic designers, and photographers, NPUs can speed up tasks like object removal, background blurring, and real-time rendering. For gamers, while gamers primarily rely on CPUs and GPUs, NPUs are starting to play a role in enhancing AI-driven features like real-time ray tracing and NPC behavior. For everyday users, if you use AI-powered apps like voice assistant, facial recognition, or augmented reality, you are already benefiting from NPUs without even realizing it. So the target audience for NPUs are ideal for tech enthusiasts, professionals, and anyone who wants cutting-edge performance in AI-driven tasks. So looking ahead, the line between CPUs and NPUs is starting to blur. Companies like Apple, Intel, and Qualcomm are integrating NPUs directly into their CPUs, creating hybrid processor that offer the best both worlds. This trend is likely to continue with future devices becoming even more efficient and powerful. Food for thought. As AI becomes more integrated into our daily lives, the demand for specialized processors like NPUs will only grow. Who knows, in a few years we might see NPUs becoming as common as CPU in all devices. And that's a wrap on today's tech breakdown. We covered everything from the basics of CPUs and NPUs to the metrics that define their performance, real world examples, and even price differences. If you found this video helpful, give it a thumbs up and share it with your friends who love tech as much as you do. Don't forget to subscribe and hit that notification bell so that you never miss out the latest uploads. What questions or thoughts? Drop them in the comment below. I would love to hear from you. Until next time, stay curious and keep exploring the amazing world of technology. So before you go, let me know in the comments what's your favorite tech gadgets and how do you think CPUs and NPUs play a vital role in its performance. So let's get the conversation started. Bye bye and take care.